Hello, in this video we'll try to find some derivatives of a functions and equation of a tangent line to a given curve. If you have a given curve, so that the curve f of x, that there will be a line which touches the curve at exactly 1 point, and the line is called tangent line. So that if you have a tangent line, then we will have a point x1, y1, which intersects the line and the curve, so that we can find the equation of the tangent line using the equation formula y minus y1 over x minus x1, which is equals to slope of the tangent line, and the slope of the tangent line is not given, so that we have to find the slope of the tangent line using derivatives. So f over g derivative is expressed as f derivative times g derivative times of over g square using the quotient rule. So given f of x, which is equals to 3x over x minus 2, so the first derivative will be f derivative at x, which is equals to 3x derivative times x minus 2 minus x minus 2 derivative times 3x over x minus 2 the whole square using the quotient rule. So that the first derivative will be given by 3x derivative is 3 times x minus 2 minus the derivative of x minus 2 is 1 times 3x all over x minus 2 the whole square. So that the slope of the tangent line is given by the first derivative at the given point 1. First derivative at 1. So if we substitute 1 in the first derivative, it will be 3 times 1 minus 2, 1 times 3 times 1 over 1 minus 2 the whole square. Then it will be given by 3 times minus 1, which is minus 3, 1 times 3, which is minus 3, all over 1 minus 2 is 1, which is 1. So that the slope of the tangent line is given by minus 6. So that the equation of the tangent line is given by y minus y1 x minus x1, which is equals to slope of a tangent line. Y minus y1 is negative 3, so that minus of minus plus 3, x minus x1 is 1, which is equals to the slope of the tangent line is minus 6, so that y plus 3 is expressed as x times minus 6, which is minus 6x, minus 1 times minus 6, which is plus 6, or y, if we shift minus 6x to the right hand side, plus 6x is 6 into, if we shift 3 to the right hand side, minus 3. So that y plus 6, which is equals to 3, is the equation of the tangent line. Here we have question number 2. If f of x is e the power of 2x minus cos square x, then find the first derivative at x. The first derivative at x is given by the derivative of e the power of 2x using the chain rule. If a function is expressed as f times g of x, so that the derivative will be f derivative at g of x times g derivative at x. If the function is in the form of composition of two functions, we can find the derivative of the functions just like this. So the derivative of e the power of 2x will be e the power of 2x, since e the power of x derivative is e the power of x. So that the derivative of e the power of 2x will be e the power of x times the derivative of 2x is 2 minus the derivative of cosine square of x is, here we have twice of cosine of x, since 2 minus 1 is 1, times the derivative of cosine of x is minus sine x. Then this will be twice e to the power of 2x minus 2 times, or minus of minus will be plus twice of cos x sine x. This will be the first derivative of the given function. The third question is f of x, which is equals to ln x squared minus 3x. So find the second derivative at minus 1. The function is a combination of two functions, f of x, which is equals to ln x, and g of x, which is equals to x squared minus 3x, so that the function is in the form of f of g of x, composition of two functions f and g. So to find the second derivative at minus 1, first we have to find the first derivative and the second derivative. So the first derivative, or the first derivative at x will be, derivative of ln x is 1 over x squared minus 3x times the derivative of x squared minus 3 is 2x minus 3. Then this will be given by 2x minus 3 over x squared minus 3x. Then the second derivative will be, f second derivative at x using the quotient rule, derivative of 2x minus 3 times x squared minus 3x minus derivative of x squared minus 3x times 2x minus 3 over g squared, which is x squared minus 3x squared. So that the derivative of 2x minus 3 will be 2 times x squared minus 3x minus the derivative of x squared minus 3x is 2x minus 3 times 2x minus 3 over x squared minus 3x squared minus 3 x squared minus 3x the whole square minus 3x the whole square. So the second derivative at minus 1 will be, here we have twice of minus 1 square is 1, 3 times minus 1 is minus 1, so that minus of minus plus 3, 1 plus 3, which is 4, minus, if we substitute minus 1 over here, twice of minus 1 is minus 2, minus 2 minus 3 is minus 5, so that minus of minus, it will be 5 times twice of minus 1 is minus 2, minus 2 minus 3 is minus 5 over the minus 1 square is 1, minus 3 times 1 is minus 1 is plus 1, so that's 3 plus 1 is 4, which is 8 minus 10 over 4, or minus 2 over 4, or minus 1 over 2. The fourth question is, if f of x is given by 5 to the power of pi x, then find the third derivative at 0. So the first derivative at x will be 5 to the power of pi x times ln 5, natural logarithm of 5, times the derivative of pi x is pi. So it will be pi times ln 5 times e the power of 5 the power of pi x. Then the second derivative will be pi times ln 5 is constant number, so that pi times ln 5 times the derivative of 5 the power of pi x is 5 the power of pi x ln 5 times the derivative of pi x is pi, so that it will be pi times pi, which is pi square, ln 5 times ln 5, which is ln 5 square, ln 5 square times 5 to the power of pi x, 5 to the power of pi x. Then the third derivative will be, here we have pi square times ln 5 square times 5 to the power of pi x times the derivative of 5 to the power of pi x, 5 to the power of pi x times ln 5 times the derivative of pi x is pi. So this will be pi cubic times ln 5 the power of 3 times 5 the power of pi x. So that the third derivative at 0 will be, here we have pi cubic times ln 5 cubic times 5 to the power of 0. Any number the power of 0 is 1, so that it will be pi times ln 5 the power of 3 will be the third derivative at 0. Question number 5. If h of x is given by f of 3x squared plus 1 over x minus 1 and f derivative at 0 is 0, f derivative at minus 1 is 2, f derivative at 3 is minus 3, then find the h derivative at 0. So h derivative at x will be f derivative at 3x squared plus 1 over x minus 1 times 3x squared plus 1 over x minus 1 derivative. So if we use the chain rule, it will be f derivative at 3x squared plus 1 over x minus 1, which is equals, times the derivative of 3x squared plus 1 is 6x times x minus 1 minus the derivative of x minus 1 is 1 times 3x squared plus 1 over x minus 1 the whole square. This is h derivative at x. Then what will be h derivative at 0? So if we substitute 0, then it will be f derivative at, here we have 0, 0, 1 over minus 1 is minus 1 times 6 times 0, this is 0, then 3x squared, it will be 0, so that minus 1 over 0 minus 1 is minus 1 the whole square, it will be plus 1. So this will be f derivative at minus 1 times minus 1. F derivative at minus 1 is given, which is 2, twice of minus 1, which is minus 2. The first derivative at 0 is minus 2. Question number 6. If f of x is given by e to the power of minus 2x, then find the derivative of n, the first, second, third, fourth, and the nth derivative. So the first derivative will be e to the power of minus 2x times the derivative of minus 2x is minus 2. So this will be minus 2 times e to the power of minus 2x. Or f derivative at 0 will be minus 2, since e to the power of 0 is 1. Then the second derivative will be, here we have minus 2 times e to the power of minus 2x times the derivative of minus 2x is minus 2. It will be minus of minus 4 times e to the power of minus 2x. So that the second derivative at 0 will be 4. The third derivative at x will be 4 times e to the power of minus 2x times the derivative of minus 2x is minus 2, which is minus 8 times e to the power of minus 2x. So that the third derivative at 0 will be, minus 8, minus 2 plus 4, minus 8 plus 16, and so on. So that the nth derivative at x will be minus 2 the power of n. Minus 2 the power of 1 is minus 2. Minus 2 square is 4. Minus 2 cubic is minus 8. So that the nth formula will be, the nth derivative will be minus 2 the power of n. If f of x is given by ln of x times the square root of x, then find the first derivative at x. X times square root of x can be expressed as x the power of 1 times x the power of 1 over 2, or x the power of 1 plus 1 over 2, which is x the power of 3 over 2. So that this will be ln x the power of 3 over 2. So the first derivative will be 1 over x the power of 3 over 2, since ln x derivative is 1 over x, then times x the power of 3 over 2 derivative. So the derivative of x the power of 3 over 2 is 3 over 2 times x the power of 3 over 2 minus 1, which is 1 over 2 over x the power of 3 over 2, or 2 over 3 into x to the power of 1 over 2 minus 3 over 2, which is equals to 2 over 3 times x to the power of 1 over 2 minus 3 over 2 is minus 1, so that it can be expressed as 2 over 3 times x. The next question is, if f of x is k times ln x plus e the power of 3 sin x, and if the second derivative at pi is minus 1, then find the value of k. So the first derivative at x will be k times, k is constant number, so that the derivative of ln x is 1 over x, plus the derivative of e the power sin x is e the power of sin x, then the derivative of sin x is cos x, so that the first derivative at pi is, sorry, the second derivative, the given is the second derivative, so we have to find the second derivative, so that the second derivative at x will be, here we have k over x, which is minus k over x square, plus derivative of cosine x, or we have to use the product rule, so that the second derivative will be, here we have derivative of k over x is minus 1 over x square, plus cos x derivative times e the power of sin x, plus e the power of sin x derivative times cos x. So it will be, the second derivative will be minus 1 over x square, plus the derivative of cosine of x is minus sin x times e the power of sin x, plus the derivative of e the power of sin x is e the power of sin x, so that derivative of sin x is cos x times cos x is cos square x. So the second derivative at pi is minus 1. So if we substitute pi, this is k over x square, so the second derivative at pi will be minus k over pi square, minus k over pi square, minus sine of pi, sine of 90 degree is 1, so that e the power of 1 is e, plus cosine of 90 degree is 0, so that this will be 0, so that this is equal to minus 1, so that minus k over pi square, which is equals to, shift e to the left hand side, so that to the right hand side, minus 1 plus e, then multiply both sides of the equation by pi square, so minus k will be minus pi square plus e times pi square, or k will be pi square minus e times pi square. This is the value of k. if the second derivative is minus 1. If x squared plus xy, which is equals to 10, then find dy by dx. dy by dx. So if you derivate, or if we find d by dx of x squared plus x times y, which is equals to 10, then we will derivate x, assuming that x is differentiable at y and y is differentiable at x. So if you derivate x, it will be 2x plus the derivative of x times y. The derivative of x is 1, 1 times y is y, which is equal to derivative of 10 is 0. Then we will derivate y, assuming that x is constant number, so that the derivative of x squared is 0 and the derivative of y is 1. 1 times x is x dy by dx, which is equals to 0. Then to find dy by dx, shift to x plus y to the right hand side, so that x times dy by dx will be minus x minus y. Then divide both sides of the equation by x, then dy by dx will be minus 2x minus y over x. So we can substitute x at x is equal to 2. X is equal to 2. So it will be minus 4 minus y over 2. Thank you.